The purpose of this video is to overview the first part of our analysis module, specifically our availability and power curve applications. This enables you, as an engineer or an asset manager, to manage historically what your availability has been, reallocate downtime events, and also see what turbines are underperforming or overperforming using our power curve application. The first part in using our availability and power curve applications is to configure an asset model for all of your assets in Bazefield. To do that, we'll go into our administration module, configuration page, and our asset models page. This is the list of all the inverters or the turbines that you have installed across your fleet. As an example, let's scroll into the Vestas V100. This is basically your landing page that contains your site-specific power curve for the Vestas V100 and the alarm list for the V100. So here's the power curve and the alarms. So what we do is, as we read in these integers from the OPC or ODBC data source, we connect this alarm with an allocation category. This is basically a category for availability, like turbine, BOP, environment. It essentially tells you the root cause of this alarm. So we group all the generator alarms, for example, to generator, or all the gearbox alarms to a gearbox category. We also allow you as a user to manage your own categories. So out of the box, we'll give you IEC and GADS as your availability categories for our application or availability application. So for example, our GADS performance categories are all listed here. These are the same ones you'll see in your NERC formal documentation for wind farm reporting. However, if you want to do more downtime categorization and availability management, say to a contractual basis, you can simply add that into Bazefield by clicking New here and uploading a simple Excel spreadsheet with a list of the categories you want to classify your downtime under. Now that you know how to configure an asset model within Bazefield, let's hop into our availability and power curve applications. To access these applications, you go into Analysis, and it's the first two that pop up. So let's scroll into our availability application, and that brings you into a home page which gives you all the historical chunks of time that turbines of this wind farm were down. So our availability application is tied in with our filter. So let me switch across the screen here. What you're looking at here is a certain time frame, June 11th to July 11th. You're looking at a certain wind farm, and you're looking at all the assets within that wind farm. You can again drill down on what specific asset you want to look at. So if you just want to look at the downtime periods for, say, turbine 3, you just select that, hit apply, and the allocations for turbine 3 will pop up. So this just gives you an idea of what happens with our filter application. Similarly, if you just want to look at the last 7 days, if you want to manage your availability the last 7 days, you just hit last 7 days. We'll hit apply to apply these filters. Now we're looking at all the assets past week, when they were down, and why they were down. So let me describe the screen here first. Here we have the date range this asset was down. We'll have the asset number, and this works for wind or solar. And then we'll have the category and root cause alarm of this downtime. So basically the root cause alarm triggers the downtime period to start, and then the category that you associate with that alarm is the category that shows up here right above it. We also give you an estimate of the lost kilowatt hours and the lost revenue associated with this allocation. You can also filter that, or sort that by ascending or descending amounts. So for example, if you wanted to look at your allocations from which ones cost you the most megawatt hours, you can just sort them descending to get your most important stops up front directly. From there, what you want to do then to manage your availability is to basically modify these periods of time as you see fit. So let's start with this one, turbine 1. Here we have a chunk of time for 20 hours where we had a pause press on keyboard alarm, which is typically like a maintenance-based alarm. That was placed in a wind turbine category. So it's not very descriptive. So you as an asset manager or site manager might want to override that default allocation that Bazefield did. To do that, you just click override. That will open up a new editing menu here with different editing options. When you click edit, this will now give you a drop down. So if this pause pressed on keyboard, this maintenance event was associated with, say, the rotor or the gearbox, you just select that category, you hit save, and now you've saved that allocation as a different category. So that's the first step in reallocating your downtime. You can also change the root cause alarm that caused this. So for example, if I drill down into this allocation, Here you see all the alarms that have come in nearby this allocation, and you can toggle through those in time by clicking older or newer here. If you wanted to set the root cause alarm as something other than pause pressed on keyboard, you could just scroll to any of these alarms, let's say this grid voltage alarm, and just say set cause. Click OK, and you can see now the root cause alarm has dynamically changed in the user interface. You also might want to split this allocation into multiple time periods. For example, when you have an inspection, or a turbine might go in a fault, and then you might have a technician visit the turbine for 5 hours, and then you might be waiting on parts for the next 4 days. So you might want to change that one allocation into 3 independent allocations. There you can use our split command. That will actually split that allocation up and allow you to categorize those 3 different allocations completely independent of one another. The other great thing you can do in this screen is to add a label or a hashtag to a certain allocation. So for example, if we go back to our pause pressed on keyboard one that we're working on, if we go back to edit, you see that there's this little labeling screen. This is a custom hashtag or a custom text field that you can enter in that has auto-completion built in based on your previous labels. So if this was an end of warranty maintenance, you could add a little end of warranty hashtag to that allocation. You could also do that in bulk too. So for example, if we scroll back up here, and all 3 of these were end of warranty maintenance allocations, you could do bulk labels and add a label to all 3. You can see it's auto completion based on your previous labels. Hit save, and now there's labels added to all 3 of those. You can also do bulk operations to change the category. So say, for example, you had 6 or 7 turbines go down because of a feeder, or feeder line or a breaker going down. You can select those 6 turbines. You might want to do a bulk operation to change the category. Here we then just select the category we want. Perhaps it was a balance of plant since it was a feeder trip. You could even enter that in as a comment. Hit save. And that will actually talk to our data engine, our database. And now you can see that all those allocations have been changed to balance of plant. And you can see that our little custom comment has also shown up here. This will give you the exact user who provided the comment and when they provided the comment to give you some connotation. So it's really, the labels and the comments really help you to manage and incorporate qualitative information about the site into the quantitative data feed that you get from Bazefield. So the next thing from this screen, you might want to get a more kind of statistical look at what categories and what turbines are losing the most megawatt hours. From there you can toggle right into our statistics menu here. Again, what we're looking at is defined by the filter, so we're looking at the last month of data, as all of the turbines on this wind farm. And we're looking at a pie chart now, breakdown of the lost energy caused or in each one of these categories. So we have balance of plant, external, electrical, etc. So again, as you click a category, the KPIs for that category dynamically pop up here on the left-hand screen. You can also see what assets are affected the most within that category. So if you want to see the turbines most affected by electrical issues, you just deep dive into the electrical category, and that shows you the list of turbines that are all affected in terms of megawatt hours lost. So you can sort by lost megawatts or lost dollars here. So essentially we take the megawatt hours lost, multiply it by either your PPA or your spot market price, depending on how your financials and the plan are organized, and we display them both here in the table, and you can sort through them by which ones are causing you the most lost money or lost megawatt hours. So any of these categories you can drill down into if you want to see what turbines are causing the most control system allocations. You just dive into control system, and there you go. You have turbine T35 that has your most reliability issues with the control system. Again, you can also look at this in terms of a bar chart or a waterfall chart. And you can also, again, toggle by categories. Instead of looking at it from a category perspective, you can look at it from an asset perspective. So as that recalculates the data live, let's go back to a pie chart. Now you're looking at a breakdown of what assets themselves are causing you the most lost energy. These are your top dogs, more or less. And as you click the turbine, you'll see that the KPIs, again, dynamically update as you click that turbine. How many lost megawatt hours, lost revenue you have because of that turbine. And drilling down here enables you to see what categories are hitting the most in that turbine. And you can do this for any allocation system as well. So up here, we're looking at the GADS system classification according to NERC guidelines. If you wanted to look at this from an IEC perspective with IEC categories, you can just toggle down, click IEC, and that will dynamically recalculate all your categories according to the IEC standard. That could also be your own organizational standard in your allocation types that you've loaded in. So now you can see that the category names have changed. This is more of an IEC convention. So we enable you to manage your downtime however way you need to manage it, either contractually or international standards with GADS and IEC. While the availability statistics screen give you an overview of your entirety of lost energy for a certain period of time, you also might want to look at your availability in terms of a time series perspective. To do that, you can start with our allocations menu, which we introduced you to, and you can click any of these allocations to dive deeper into a Gantt chart of this specific turbine. So if we wanted to look at, say, turbine T25, we click that allocation, and the time series of this turbine pops up here. The x-axis here is day of the month, and the y-axis is a turbine. As you scroll through the time periods, you can actually pinpoint when this turbine was down in terms of time. And as you stop, any allocations that show up on the Gantt chart itself will pop up in the list here at the bottom. So you can do this and use this scroll button dynamically, and this will refresh as you pull in new allocations. You can also look at this from an entire park perspective. So if you want to look at turbines here on the y-axis and time here on the x-axis, you can now see when turbines have gone down. If you perhaps had a low wind period or a feeder go down, you'd see a big vertical line of red bars, which you can kind of see here a little bit. You can see when turbines are down longer than other periods. You can see turbines that might be stopping repetitively based on a series of red bars that continually pop up. So a lot of different visual indicators which we provide you in addition to just calculating your availability and your statistics and allowing you to recategorize your downtime. Now that you know how to manage your availability and downtime using Bazefield, it's important we teach you how to manage your uptime and performance using our Power Curve application. That's found here on the left side, right underneath the availability application. So as that loads, I'm going to move over to the right side of the screen and introduce you again to the filter. The filter commands what data is being displayed in the visualization itself. In this case, we're looking at 10 days, we're looking at one wind farm, and we're looking at two turbines, 9 and 11, that are nearby one another to do an analysis of those two. I'll introduce you to a few filtering commands off the top here. Filtering is a big part of power curve analysis. So, for example, if you wanted to remove any low wind periods from your power curve because the turbine's non-operating in those conditions, you could go down to our conditions in the filter, select tag here, and start to type in wind speed. And that will auto-complete to the wind speed tag. Let's select it. Say we only want to keep our 10-minute data when the wind speed's greater than 4 meters a second. You just hit that, hit apply, and now this filter dynamically filters out all the scatter points, the 10-minute points below 4 meters per second. So that's one way of filtering. At any point you can add another tag or you can clear an existing filter just by hitting apply. So now we go back to the default view, which looks at all your data. You could use a filter by operational state. You could use a filter by, say, a curtailment set point, or perhaps a component temperature if you want to look at the effect of a power curve on a certain, say, a gen bearing temp. The other cool filter option we have is with the actual eraser tool. When you click that, what you can do is basically scroll over these individual points if you want to clean up some outliers and just remove them manually. So there, once we've removed those points, you see our red polynomial fit, which let me pop up the legend here so you know what you're looking at. The red polynomial fit that we automatically calculate dynamically updates based on your filters. So this will adjust according to how you select. So you might want to actually take this red polynomial fit and do something with it. You might want to just save it. So if I scroll over to the fitted curve here, which pops up, and I just hit save, this will allow me to save a title and description. Perhaps I want to do an analysis on February 2017's power curve. I could type that in here, hit save, and when I do that, it will pop up into the list, my library of saved power curves, and we store those forever. At any point, you can pop those back up in your visualization by clicking them here, and now you can see that a new test power curve has been saved, and you can toggle that on and off also by clicking the filter. The other thing you can do with that fitted red polynomial is you might want to improve the way that we do lost energy calculations. By default, Bazefield will use the contractual curve here, shown in orange, which we configure in our asset models. We'll use that in conjunction with the wind speed to estimate lost production. But you might have certain issues with the anemometer of the turbine, which is underperforming itself, and you might want to change the reference curve for how we do that calculation. If you wanted to do that with this fitted curve, you would just hit Use. This will pop up that fitted curve in a new screen, and you can apply that to our lost energy model either on just this turbine 9, or you could apply it to every turbine on this site of the same model. So if you had 50 turbines of the same type, it would apply it to all of them. You would just hit apply, and that would dynamically tell our calculation engine to update its logic. The other great thing you can do is if you want to look at more than one turbine's power curve in one view, you can either toggle up here and choose what turbine you're looking at, or you just click Compare Turbines here. This will allow you to look at now turbines 9 and 11 in the same view and see if one is underperforming another, which in this case you can clearly see here in green is turbine 11 has a wicked parameter issue near the knee of the power curve. That's typically 5 to 10% energy you're losing, and it's typically something that is easily fixable with that turbine. And you can work with the OEM or your site technicians to fix that. You might also want to set some type of alarm on that turbine because it's underperforming. To do that, we can scroll down to turbine 11 here. Say, for example, we want to set a performance alarm on the contractual curve. We want to make a condition where it checks every hour if the turbine's underperforming. And if that turbine is underperforming by 10% or more to that contractual curve, we can throw a custom Bazefield alarm. And we can do it just for this turbine, or we can distribute that alarm to all the same turbine model in our fleet. And you just hit save, and now it's going to check for an underperforming asset every hour. And when those assets are underperforming, you actually get an indication back in your asset operations. So if I scroll back into there and go into asset operations, you can see our visual indicator that that turbine is in fact underperforming. So any tag in Bazefield, even beyond underperformance, can be set as a custom alarm, and those custom alarms can actually be integrated right into your asset operations menu to give you more visual indication of turbines underperforming. Finally, the last piece of our power curve application is wind and energy roses. So between toggling, just looking at wind speed and power, you can go up here in the link dashboard, hit wind rose, and you can pop up wind roses for all of the turbines you have selected in the filter. You can also look at energy rose, which is the frequency of energy coming in each wind sector itself. And these are widgets themselves which can be added back into the monitoring section. So very accessible to add these in different parts of the product. Basically, any visualization you see in Bazefield can be added to any other menu that you see. So it's completely up to you how you want to see it. The final part is just looking at the raw data that comes in as part of your power curve. And we'll get more into raw data exports, raw data downloads in our next video, which focuses on our plot, our trend tool, and our data export tool.